Rationalizing radical denominators. So when you have a problem like this, 17 over the square root of 2, there's kind of a convention. We're not going to go into why we do this or much explanation today, but the idea is we don't want our denominator to be irrational. So a radical is an irrational number, right? It doesn't terminate. The square root of 2 goes on forever. It can't be written as a fraction. And so we don't want that in our denominator. Just trust me on that one for now. The way to get a radical out of your denominator is to multiply your fraction by 1, right? But 1 has a lot of forms. So what 1 are we going to multiply this fraction times? We're going to multiply this times 1. So what is 1 going to be? Because we won't change our fraction if we multiply it times 1. Right? We will change it if we square the denominator and square the numerator. That's totally changing our fraction to a different fraction, right? I'll do a simple example. If I had 1/2 and I squared the numerator and squared the denominator, I'd have 1/4. 1/2 is not equal to 1/4, right? So I can't square this to get rid of my radical. I can't multiply by the reciprocal. Think about this one. 1/2 times the reciprocal equals 1. And 1/2 is not equal to 1. So if I multiply by the reciprocal, I'm also changing my fraction. I don't want to change the value of my fraction. I want to have the same value for my fraction. I just want to get this square root of 2 out of the denominator. Yeah.
Could you do times it by square root of 2 over the square root of 2?
Yeah. So I'm going to multiply by 1, but my 1 is going to look like this in this problem. The square root of 2 over the square root of 2. So I'm not changing the value of my fraction because I'm multiplying by 1, but this will have the effect of getting the radical out of my denominator. So I'm going to have 17 square roots of 2 in the top, and in the bottom, the square root of 2 times the square root of 2 is just 2. One trick with this, a common mistake would be to put 4 here, right? Because you think, oh, 2 times 2 is 4, but remember the square root of 2 times the square root of 2 is the square root of 4, which is 2. Yeah?
So it's okay if you have a square in the top.
Totally fine to have a radical in our numerator. We don't want it in our denominator. Okay. For today, we're just going to leave it at that. So this is kind of the simplest type of an example, is when we just have one square root down here. And then when we finish, there's nothing else we can do. But sometimes there will be something else you can do. So this is our first example, right? And I'm just going to quickly kind of label some things. So we wanted to get the radical out of the denominator. So what did we do? We multiplied by 1, and then we had no radicals. So we had a radical in our denominator, we needed to get that out, multiplied by 1, and this is kind of the trickiest step. You have to figure out what to multiply by. In this case, it's pretty clear, right? The square root of 2 needs to be multiplied just by the square root of 2 to clear it out. And then we just have a simplified fraction, and we're just checking at the end that we have no radicals left in our denominator. So there's a couple other things that can happen that will add extra steps to this. The first one is if I had something like 3 over the square root of 8. So if I have 3 over the square root of 8, what I want to do first is simplify this radical. So these are kind of like extra steps. And our extra step here is to first simplify the square root of 8. So in that case we would have 3 over square root of 4 times the square root of 2, which is 3 over 4 square roots of 2. And that'll just make it a little easier. Now, instead of multiplying by the square root of 8, we can just multiply by the square root of 2.
Wouldn't it be like 2 to the square root of 2?
Yeah.
Oh, I'm sorry. I made that mistake that I was talking about. Right? Okay. 3 over 2 square roots of 2. We're going to multiply times the square root of 2 over the square root of 2. So we have 3 square roots of 2 over. And now 2 times the square root of 2 times the square root of 2 is 2 times 2, which is 4. Now, you don't necessarily have to do that here. So let's take a look at what would have happened if we had just multiplied by the square root of 8. So if I had just multiplied immediately times square root of 8 over square root of 8, I would have had 3 square roots of 8 over 8. And then I would have had to simplify up here. So I would have had 3 times 2 times the square root of 2 over 8. Because 8 is 2 square roots of 2. Then I would have had to reduce my fraction, giving me 3 times the square root of 2 over 4. So eventually I would have gotten the same answer if I hadn't simplified at the beginning. But I think this is maybe one extra step. Feels like an extra step to me. Compared to this one. Now sometimes that will just happen though. So sometimes you'll get to the end and you will have to reduce your fraction. Right? And there was nothing necessarily ahead of time that you could have done to foresee that or prevent that. Okay? So if I had something like, say I had 20 over the square root of 5. There's nothing here that I can reduce. Right? The square root of 5 is just the square root of 5. It's a prime number, so I can't break it down into anything. So I'm going to just multiply times square root of 5 over square root of 5. But now I'm going to have 20 square roots of 5 over 5. And now there's a step here. I need to reduce this fraction. So at the end, you always want to check as well to see if you can reduce. And in this case, I would actually just get 4 square roots of 5. Totally got rid of the denominator in that case. So 20 square roots of 5 is 20 over the square root of 5 is actually equal to 4 times the square root of 5, which is a little bit weird to think about. It's not something that I think is obvious at first, but this definitely feels simpler than this. And this is part of why we're learning about rationalizing denominators, making things simpler. So make sure you check at the beginning if you can simplify your square root. Make sure you check at the end if you can rationalize. Right? And then the last thing, can I erase this? No, that's kind of quick. The last kind of trick is sometimes you'll have a square root in the top of your fraction, in your numerator. So like if I had 3 square roots of 2 over the square root of 6, watch what's going to happen here. What am I going to multiply by? Square root of 6 over square root of 6. I'm looking at my denominator, right? That's what I want to clear out. So multiply times the square root of 6 over the square root of 6. I don't care about the square root of 2. That's totally fine up there. So all I need to worry about is this denominator. That's going to give me 3, and then I have the square root of 2 times the square root of 6 over square root of 6 times the square root of 6 is 6. Okay. So this is equal to 3 times the square root of 2 times 6. So we're kind of using that rule that you've used to break up radicals in reverse. We're putting these together now.
Would it just be 12 though?
Yeah, so this is 3 square roots of 12 over 6. But wait a second. The square root of 12 can be simplified. So I'm going to move down here. We actually have 3. The square root of 12 is the square root of 4 times the square root of 3. So what I really have is 6. This is 2. Square root of 4 is 2. Square roots of 3 over 6. And now look, now I can even cancel this. So all of this is just equal to the square root of 3. This whole fraction. Which is pretty surprising. It seems weird that this would all equal this. But that's what we need to look out for, is all the stuff that you've been learning so far comes into play with these fractions. Right? You need to recognize when you can simplify a radical. You need to recognize when you can reduce a fraction. All that kind of stuff. So that's the basics. And then I'm going to teach you one little trick. Because I think you guys can handle more. So sometimes your denominator will not be one term. So what if I had 2 over the square root of 3 minus 1? If I multiply this times the square root of 3, the distributive property would apply. So then I would still have a square root in my denominator. I would have 2 over, this would cancel, square root of 3 times the square root of 3 is just 3, but then I would have 1 times the square root of 3, which is the square root of 3. So I would still have this square root down there. If I have more than one term in my denominator, I have to do something a little bit different. And this is where I asked if you guys had heard of the difference of squares. So difference of squares is a special case of what you guys know as FOIL, right? So FOIL is when we have like 2x plus 1 times 3x plus 2, and we do the first numbers, so 6x squared, the outside, the inside, and the last. Just to review what FOIL is, right? Well, in a difference of squares, the two factors are called conjugates. So I would have something like this, 2x plus 1, and then the other one is the same numbers, but a minus sign. And watch what happens when we FOIL this. 2x times 2x is 4x squared. 2x times negative 1 is minus 2x. 2x times positive 1 is plus 2x. And then 1 times 1 is negative 1. So look at this. Minus 2x plus 2x. This is all going to drop out. And so 4x squared minus 1. This is why it's called a difference of squares, because these are both perfect squares, and they're subtracted. There's no middle term like we usually have with FOIL. With FOIL, we usually have 3 terms. But in a difference of squares, you're going to just get. Okay. And the key for you to understand right now is that we have 2 factors. One of them has a plus, one of them has a minus. We'll be coming back to this as we learn about quadratics, parabolas, and that sort of thing. But for now, it's going to be useful for clearing these types of denominators. The square root of 3 minus 1 can be cleared by multiplying by the conjugate. So I'm going to multiply this by the square root of 3 plus 1 over the square root of 3 plus 1. So I took my denominator, and all I did was change the minus to a plus. Now watch what happens. I'm going to use FOIL. First term, square root of 3 times the square root of 3 is 3. Then I have square root of 3 times 1. So far this isn't looking good. I have a square root of my denominator, which is what I was trying to get rid of. But watch. Now I have negative 1 times the square root of 3, so minus the square root of 3. And these are going to cancel each other out. Then I have negative 1 times positive 1, which is just minus 1. In my numerator, I'm going to just use the distributive property. So I have 2 square roots of 3 plus 2. And then I'm going to rewrite this. I have 2 square roots of 3 plus 2 up top. And down bottom, with these canceled out, I just have 3 minus 1, which is 2. My final answer, 2 square roots of 3 plus 2 over 2. And then actually I could cancel a 2 out of all of this, which is kind of an extra step. Square root of 3 plus 1. Because I cancel a 2 from here, a 2 from here, and a 2 from here. That won't always happen. You won't always get to cancel out at the end. But okay, so I just want to quickly show you guys some examples. And I want you to just say, what would you multiply by to clear the denominator? So if I had this, 5 over the square root of 7, what would you multiply that by to clear the denominator? Good. We would multiply times square root of 7 over square root of 7. What if I had 6 minus 2 over the square root of 3?
Square root of 3 over square root.
Yeah, square root of 3 over square root of 3. What if I had this? 4x over the square root of x. What would you multiply by? Square root of x over the square root of x. So sometimes you will see variables with these, but it doesn't really change very much. So what if I had like 3 over 2 square roots of 2x? What would you multiply this by to clear that? Square root of 2x over the square root of 2x. Okay. What if I had square root of 3 over 4 square roots of x? How would we clear this denominator? multiply times the square root of x. What if I had this? 7 over the square root of x plus 2. Yeah, we'd multiply times the square root of x minus 2 over the square root of x minus 2. Right? And these would, the middle terms would cancel. So in the bottom we just have x minus 4. Wouldn't that cancel that? We'd have no more radicals. In the top we would have to use the distributive property. Now what if I had something like this? 3x plus 1 over the square root of 4 plus x. What would I multiply by? Square root of 4 minus x. And what's going to happen in the top when I multiply this times this? What am I going to have to remember to use? I have two imagined parentheses here. Yeah, you would have to use FOIL in order to do this correctly. Okay.